Welcome to Joystick, my friend. In this video you will learn merge sort algorithm. Not only you will learn how merge sort algorithm works, but you will also learn what is its time complexity and how to write the merge sort algorithm programmatically. I am going to tell you everything step by step. All you have to do is watch this video till the end and do not skip watching any part of this video. So let's begin. Alright, so this is the array which we are going to sort using the merge sort algorithm. So how does it work? How does the merge sort algorithm work? So what we do in merge sort is we divide the array into two halves. Then we sort each half and then we merge the two halves together, and we need to keep repeating this process until the array is sorted. This is the functionality of merge sort in the simplest terms. Don't worry, I'm going to explain everything in detail and it's starting right now. Before that, you must know that merge sort is a popular algorithm for sorting large data sets because it works on divide and conquer approach. It is relatively efficient and easy to implement, which is why you must learn it. Alright, so the first step will be to break this array into two halves. This is an array of 7 elements. So the first half is going to contain 4 elements and the next half is going to contain 3 elements, like this. Now we'll pick the first half, the one on the left, and break it down into two halves as part of step 2. So let's do this. Alright, you can see that as part of step 2, this particular array has been broken into two halves. It contained 4 elements. So the two halves are going to contain 2 elements each, 39 and 27 in the left array and 42 and 4 in the right array. As part of the third step, we will divide this array, the leftmost array, into two halves. They contain 2 elements. So the broken halves are going to contain 1 element each. Now we can't do further division because the atomic units have been reached. That means we have reached a level by dividing the leftmost arrays again and again, the level at which we have single numbers only. So this is the stage at which the division is going to stop for every array. That means when we have reached the smallest units, that is size 1 or single numbers in simpler terms. Now in step 4, this particular array will be checked by the algorithm to see if there is any scope of further division, and since it's a single element, hence there is no scope of further division. In step 5, this array will be checked to see if there is any scope of further division, and there is no scope of further division because this is a single element. So now the algorithm is going to know that it cannot divide these arrays further, and so the merging process will begin, and we will start merging the elements based on the comparison of the size of elements. So as part of step 6, 39 and 27 will be compared against each other and they will be placed in a sorted manner, combined in a list like this. Okay, alright, this will be step 6. Now you need to keep in mind the order of the steps because that is very important to learn the algorithm. Now let's follow the same procedure for this array and it will be step 7. So as part of step 7, 42 and 4 will be split into two halves like this. The algorithm will further try to divide this part of the array into 2 as part of step 8, where it's going to find out that we have reached size 1, so no further division is possible. As part of step 9, this part will be checked by the algorithm to see if there is any scope of further division, and there isn't any. So the algorithm is going to again find out that we have reached a level where there is no further division possible. This will be a signal to the algorithm that the merging process will now begin. So the merging process will now begin for this part. 42 will be compared against 4 and these two elements will be placed in a sorted manner in a new list like this, and this is going to happen as part of step 10. Okay, alright, so as part of step 11, these two arrays will be compared against each other and the elements of these two arrays will be placed in a sorted manner, combined. You can see that these individual arrays are already sorted. So now if we compare them against each other, then 4 will be placed first then 27, then 39, and then 42. Alright, so the resultant array after these two arrays are compared and the items are placed in a sorted manner will be this. So now you see how the merge sort algorithm sorted this half of the array. It sorted this half, it sorted. You saw that? So guys, again I am saying, when you will practice the merge sort algorithm, focus on the ordering of these steps, as these steps are very important to understand the merge sort algorithm correctly. We will shift our focus on the second half now. As part of step 12, we break it down into two halves like this, and as part of step 13, this array will be divided into two halves like this. Now as part of step 14 and step 15, these arrays will be checked by the algorithm to determine if there is any scope of further division, and there isn't any. So the merging process will begin. As part of step 16, 10 and 83 will be compared and will be placed in a sorted manner in a new list over here. So let's do that. Alright, so the step 16 is executed. Now as part of step 17, the algorithm will try to divide this part into two halves, where it's going to realize that no further division is possible. Here only at this level the atomic unit is reached. So we are going to write step 17 over here, and this element will be carried forward like this only. Okay. Now as part of step 18, these two arrays will be compared as part of the merging process, and the elements will be placed in a sorted manner. So the first element will be 10 from here, then 11, and then 83. Alright, okay, we are good with step 18 as well. And finally the last merging process will occur as part of step 19. These two arrays are already sorted at an individual level. So now merging these two arrays in a sorted manner won't be a big task. Let's put them over here. So 4 will be the first element, then 10, then 11. 10 and 11 have come from this array, 4 came from this array, then it will be 27 from this array, then 39 and 42 again from this array, and finally we are going to get 83 from this array. So the step 19, the final step, is going to yield this array, which is the sorted version of this array which we just sorted using the merge sort algorithm. Now let's work on building the merge sort algorithm. There will be two functions for sure. One will be the sort function and the other one will be the merge function. So let's first work on the sort function. So it will be void sort. And what parameters it's going to have? The first parameter to the sort function will be the array. The second parameter will be the left index. So we are going to denote it by L. And the last parameter will be the right index, which we are going to denote using R. Okay. And the first call from the main function to this sort function will be sort ARR, which is going to be our main array. 0, that's the starting index, and finally the length of the array. Okay, let's declare and initialize the array over here. So it will be int ARR new int square brackets, and then the array elements, which are going to be 39, 27, 42, 4, 10, 83 and 11. Obviously I am writing the algorithm in Java, so let's make it static to avoid any red marks. Within the sort function, the first check that we are going to perform is to find out if the left index is less than the right index. So we are going to write if L is less than R. Okay, this condition is necessary. When it is false, it means we have reached a portion of the array that has single elements only. Okay, if this is false. Otherwise the left index will be always lesser than the right index. Alright. Now the next line of code will be to find the middle point of the array so that it can be broken into two halves. Remember that this sort function is responsible for dividing the array into two halves. That is the purpose of this sort function. So we are going to write int m, which is going to be the middle index. It will be L plus R minus L divided by 2. Alright. So in our case, the first index is 0 and the rightmost index is 6. So the midpoint is going to come out as 0 plus 6 minus 0 divided by 2. So it will be 3. And you can see the first left half has elements from index 0 to index 3. Now we are going to make a recursive call to the sort function for the first half, the left half. Okay. So it will be sort ARR, that's the array, L comma M. Alright, the left index here will be 0 in this example, and the rightmost index will be denoted by M, which will be the midpoint. So the midpoint came out as 3, so it will be 3, and that's the first half, 0 to 3. And now we are going to make another recursive call, and that is going to be for this half, the right half. So the first parameter will be array again. The leftmost parameter in this case will be m plus 1, and the rightmost parameter will be r. Alright. See, the second half started from index 4. So 4 will be m plus 1, and then it's going all the way to the index r, which is 6. Hence this call. And finally, we are going to make a call to the merge function to merge the sorted halves. So it will be merge ARR L M R. The merge function is going to take in 4 parameters. Alright. So the merge function will be called over here. Alright. It's going to take in array. The leftmost parameter will be 0. The value of m in this case will be 3, and the value of r will be 6. It's going to be clear to you when we are going to write the merge function. To understand all the recursive calls made by this sort function, tag it along with what I have explained over here, and it's all going to make sense to you if you follow the steps correctly. Now we are going to work on the merge function. So let me write it over here. It will be static void merge, and it's going to contain the parameters array, then left index, middle index, and the right index. Alright. Now let's assume we are here at this step. We need to merge these two sorted arrays, which are the part of the same array, but there are 2 in our eyes separated by these indexes. Alright, what's the first thing that we are going to do? First, we'll find the size of the 2 arrays. Okay, so it will be int n1, which is going to represent the size of the left array, and it will be m minus l plus 1. Okay, and then it will be int n2, which is going to represent the size of the right array, this array, and it will be calculated using r minus m. So assuming that r is 6, m is 3, and l is 0, the size of the first array is going to come out as 4, and the size of the second array is going to come out as 3, and that's the correct size. We have 3 elements in this array and 4 elements in this array. Alright, now we are going to create 2 temporary arrays and fill them with the numbers from these arrays. The arrays that are 2 in our eyes, we are going to create. So let me reiterate, we are going to create 2 temporary separate arrays, and we are going to fill them with the elements from this array, the left array, and the right array. Okay, they are logically separated. Now we are going to physically separate them. So let me create the 2 arrays. The left array will be L. I'm going to name it L, and its size is going to be n1, and the right array I'm going to name as r, and its size is going to be n2. Okay, now we are going to write the code to copy the data into these two arrays. So it will be a for loop, and it will be int I equals to 0, I less than n1, I plus plus, and over here we are going to write L, its index will be I equals to arr L plus I. This is going to be I. Alright, and then we are going to write the code to copy this array's elements into the right array. So it will again be a for loop for int, this time it will be j equals to 0, j less than n2, j plus plus, and it will be r j, index will be j equals to arr, and this time the starting index will not be L but it will be m plus 1, and then we are going to add j to it. Okay, if you replace I with 0 and L with their appropriate values, it's all going to make sense to you. Okay, so I'm leaving this to you to figure out. Now we'll write the algorithm that is going to compare the two arrays with each other, and will keep putting elements from each of the arrays in a sorted manner back into the main array. So let's initialize the indexes for the first and the second sub array. So it will be int I equals to 0, j equals to 0, semicolon, and one more index which is for the main array, that also we'll have to initialize, and we are going to call it k. So I am going to declare it as integer, and we'll initialize it to L. Okay, you will understand everything in a minute. Now we'll start a while loop. So it will be while, and the condition will be I less than n1 and j less than n2. So the loop is going to run till both the indexes are less than the lengths of the two arrays. The minute either of the indexes becomes equal to their corresponding array length, this loop is going to stop. Alright, now we are going to compare the elements of the two arrays. So we are going to write the condition if L at index I is less than R at index j. Okay, now if the element of the left array at index I is less than the element of the right array at index j, then this element goes to index k of the main array, and we increase the index I by 1. So we are going to write arr k equals to li semicolon, and then we are going to write I and then the increment operator. Okay, else what we are going to do, we are going to assign the element at index j of the right array to the index k of main array like this, and we are going to increment the index j by 1. So it will be arr k equals to r at index j, and we are going to increment j using the increment operator. Cool. And once the right element has been assigned to the index k of the main array, we need to increment k as well. So after if and else, we are going to write k and the increment operator. There you go. This is the code that is going to put the elements from these two arrays in a sorted manner in the main array. Okay. Now obviously if one of the indexes reaches its limit, then the loop will stop. So in that case, we may have certain elements remaining in either of the arrays. Therefore, we'll have to write the code to put in the remaining elements of the arrays, if any, in the main array. So let's write the code for that. So it will be while, and the condition will be I less than n1. Okay, this I will continue from before, and if there are remaining elements in the left array, those elements will be transferred as they are into the main array. So it will be arr at index k equals to L at index I, k increment operator, that means we will be incrementing the index k, and we are going to increment I as well. Okay, And similar loop we'll write for the right array as well. So it will be while j less than into, and it will be arr at index k equals to r at index j, and it will be j increment operator and then k increment operator. Okay, let this be in sync. Let me cut this one and paste it after this line of code. And that's it. We have written the merge function, and thus we have finished writing the algorithm of merge sort. If you want a working Java program of the merge sort algorithm, then check out my GitHub link, which you can find in the description box below. This video will not be complete if I don't give you the time complexity of the merge sort algorithm. The time complexity of the merge sort algorithm is big O of n log n, which is also known as log linear complexity. It means log n operations occurring n times. This time is very much common in recursive sorting algorithms. And with this, we have come to the end of this video. I hope you enjoyed learning the merge sort algorithm from Joey's Tech. Do not stop here, as there are more sorting algorithms that you need to master, and I have created videos on a lot of them. I'll see you in the next video of Joey's Tech. Goodbye and take very good care of yourself.